Alright guys, so today we're going to look at solving equations and using bar models to do that in some cases. So if we've got the equation 3x is equal to 12, what we know is that 3 lots of x is the same as 12. Now as a bar model, a bar that's split into 3 parts, each of those parts has a value of x, would be the same as one long bar with a value of 12. Because they are equal, they're exactly the same, okay? And it's quite easy to spot from the bar that each of these x's must be 4, because that 12 needs to be shared into these 3 equal parts, okay? So if you've got an equation, a nice simple equation like this, you can see what x is going to be, okay? But that's not going to be the case for every equation that you answer. So we do need a formal method to help us with this. So if we just look at the formal working here, okay, I know that I've got 3 unknowns, but if I want to solve an equation, I want to know what a single unknown is worth. So if I've got 3 lots of something and I want to get down to 1 lot of something, I can divide by 3. So I can do 3x divided by 3, and it gives me x. Now because this is an equation, this is really important. Whatever you do to one side of the equation, you must do to the other side. If you don't, then the equation is no longer equal, it's no longer an equation, okay? So we must also divide 12 by 3. 12 divided by 3 is 4. Now that seems quite long-winded because the equation is a simple one and you can look at the bar model straight away, okay, and you can just see what x must be. But as I've said, this isn't always going to be the case, okay? So if we just look at another example, okay, this time we've added an extra kind of layer to this. We've now got 4x plus 1 is equal to 13. So 4 lots of x plus 1 is equal to 13. And this is what the bar model looks like, okay? Now, initially, you can't do what we did with the first example. You can't just share 13 into those 4 parts above it, okay? Those 4 unknowns, because you haven't got the unknowns isolated. You haven't got the unknowns on their own. This bar model here would help you a lot more, okay? Now all I've done to get from the top bar model to this bar model is I've subtracted 1 from the top bar, and I've also subtracted 1 from the bottom bar. Because if I just took away 1 from this top bar, I'd end up with something like that, and then the bars wouldn't be equal, they wouldn't be the same length, which is why whatever we do to one side of an equation, we must do to the other. Whatever we do to one part of the bar, we must do to the other bar, okay? So if I just reveal again the more formal method for solving this, we would subtract 1 from both sides of the equation, okay? Now the reason that we would subtract 1 from both sides of the equation is because we want to isolate the unknowns. And what we want to do, what that means, is we want to get these x's, these unknowns, on their own. And to do that, we need to get rid of this plus 1, okay? So if I subtract 1 from this side of the equation, I'm going to end up with 4x plus 1, take 1. These are going to cancel out, leaving me with just 4x, which is perfect. I've isolated the unknowns. But as we've mentioned, if you are to do a subtraction of 1 to the left side of the equation, you must do it to the right side of the equation. If you don't, then it's no longer an equation because both sides are not equal, okay? So we get 13 take away 1 on this side of the equation, which gives us 12. 4x is equal to 12. We've isolated our unknowns, and then we've just got an equation here similar to the one we've looked at in example 1, okay? So we just need to share that 12, we need to share it into those 4 unknowns, okay? In the formal method, we've got 4 lots of x, we only want 1 lot of x, so we can divide it by 4, which we've done here. 4x shared into 4. If you've got 4 x's and you are sharing it between 4 people, everyone would get 1x. So that's why we end up with an x there, and not 1, we end up with an x. 12 divided by 4 will give you 3. Okay, guys, we've got a couple more examples to run through because I don't want you guys to just be able to answer generic looking equations. Okay, I want us to be comfortable with any sorts of equations. So if we look at this equation, what's changed now is that the unknowns are on the right hand side of the equation, whereas the previous two equations have had the unknown on the left side. And nothing changes with this, okay? Because an equal sign doesn't mean here is the answer, it means these two things are equal. Okay, so it doesn't matter that the unknowns are on the right and the value that the unknowns are equivalent to is on the left. That's not important. The bar model will still look exactly the same. We've got your 4 unknowns, which is the same length as 12. Okay, now clearly you can see from that 4 equal unknowns adding up to 12. Each unknown must be 3. Okay, now how do we get to that? And we've already got the unknowns isolated. We've already got the unknowns on their own, nothing else with them. So we can look at finding out what a single unknown is worth. So we've got 4 lots of something. We divide by 4 to find 1 lot of that thing. 4x divided by 4 is x. 12 divided by 4 is 3. So our answer is 3 is equal to x, which is the same as x being equal to 3. Okay? The very last example for you guys to have a go at, for us to look through together. 15 is equal to 1 plus 2x. Again, the unknowns are on the right hand side of the equation. This time the unknowns are not isolated because they've got this 1 here. Okay, we don't want that 1 to be there. So this is what the bar model would look like. And now as I reveal the working, this is a better bar model for working out what the unknowns equal. Okay, so you've got 14 is equal to 2x because we've subtracted 1 from both bars to get to this bar model here. Okay, because if we subtract 1 from the top bar to get our x's on their own to isolate the unknowns, we have to do the same to the bottom bar, otherwise they're not equal. Now, the formal method would look like this. And I know this seems a lot more long-winded, guys, but in the long run, you're going to have to use this formal method. Okay, it's nice to be able to use the bars and lean on the bars a little bit until you get confident with this to make sure that you're getting the right answers. But eventually, this is what we need to be able to do because there are going to be some equations that we can't represent using bar models with very easily, okay? And we need to be able to solve them all the same. So, step 1 is to isolate my unknown. Now, I've got my unknowns here, and I need to get that on their own, so I need to deal with this. How am I going to get this bit down to 0? Well, I'm going to subtract 1 from it, okay? So, I subtract 1 from this side of the equation. I get 1 plus 2x take 1. If I collect my like terms, it's going to be 1 take 1 is 0, plus 2x is just 2x, okay? But of course, I've subtracted 1 from the right side of the equation, so I must subtract it from the left side of the equation. 15 take 1 is 14. I've now got my unknowns isolated because I've got all of the x's onto one side of the equation on their own. I've got 2 lots of something. I want 1 lot of something, so I'm going to divide it by 2. I'm going to half it. 2x divided by 2 is x. 14 divided by 2 is 7. So my answer is 7 is equal to x, or x is equal to 7. Right, guys, what I want you to do now is I want you to have a go at solving this equation. Have a go at representing it as a bar model. Have a go at solving it the formal way. Pause your video to do this, and then when you click play again, I will reveal the answer. Okay, guys, this is what your bar model should look like. 5 equal unknowns is equal to 20, okay? And this is what the formal method should look like. We've got 5 lots of something and we want 1 lot of something, so we divide it by 5. 5x divided by 5 is x. We've got to do the same to both sides of the equation, otherwise it is not equal anymore. So 20 divided by 5 is 4. So x is equal to 4. Last example, guys. Okay, so 13 is equal to 5x plus 3. So I want you to pause the video again at this point. Have a go at it, represent it as a bar model, have a go at it using the formal method, and then click play again. Okay, guys, you should have had a go at that now. So, you should have had 5 unknowns and 3 is equal to 13 on your bar model. Which means that if you subtract 3 from the top bar and subtract 3 from the bottom bar, you get this nice little 5 unknowns is equal to 10 bar model. So x must be 2. Each of those unknowns must be 2. If we just look and focus at the formal method, you want to get rid of this 3 because we want to isolate the unknown. So, to get rid of adding 3, okay, of this positive 3, we're going to subtract 3. 5x plus 3 take 3, they are going to cancel each other out to leave us just with 5x. Of course, if we've done that to one side of the equation, we must do that to the other side of the equation. So you get 13 take 3 is equal to 10. 5 lots of something is 10. We want to find 1 lot of something, divide it by 5. Divide 10 by 5, we're going to get 2 is equal to x, x is equal to 2. Have a go at the questions on Show My Homework now, guys, for me, thank you.